Welcome and introduce yourself. This slide sets the stage for everything that follows. PMI-CPMAI stands for Certified Professional in Managing AI. It is PMI's dedicated certification for professionals who lead, manage, or support AI and machine learning initiatives. Key talking points. Unlike general project management credentials, CPMAI is purpose-built for the unique challenges of AI projects: shifting data, evolving models, ethical concerns, and cross-functional complexity. The methodology blends three proven frameworks: PMI's project management standards, Agile's iterative delivery mindset, and CRISP-DM's data-centric process model. It is vendor neutral. It does not prescribe any specific tool, platform, or technology stack. The exam is 120 questions in 160 minutes and is delivered through Pearson VUE, either online or at a testing center. The prep course earns you 21 PDMPs, which counts toward renewal of PMP and other PMI credentials. Once certified, you maintain the credential by earning 30 PDUs every 3 years, roughly 10 per year. Phase I is about alignment and intent. Before any data is touched or any model is trained, the team must answer a deceptively simple question: what business problem are we actually solving? Key talking points. Many AI projects fail not because of poor technology, but because of unclear or misaligned business goals. Phase I exists to prevent that. You define what success looks like before the project starts: KPIs, ROI expectations, and the criteria that would lead you to stop or pivot. A critical output here is the feasibility assessment. Not every business problem needs AI. Sometimes a simpler rule-based system or a process improvement is more effective. Acknowledging that early saves significant time and budget. Stakeholder mapping at this stage ensures governance and accountability are established from the outset, not bolted on at the end. Think of Phase I as building the contract between the AI project team and the business. Phase II shifts focus from what we want to build to what data we have available to build it with. Data is the fuel of every AI system, and this phase is about understanding the quality, coverage, and constraints of that fuel. Key talking points. This phase is heavily influenced by CRISP-DM's data understanding step, which emphasizes exploring the data landscape before committing to a solution. Teams assess not just whether data exists, but whether it is trustworthy, complete, and legally permissible to use. Data governance and privacy compliance, GDPR, HIPAA, or sector-specific regulations are identified here, not discovered mid-project. The data infrastructure plan ensures the right pipelines, storage, and access controls are in place before data preparation begins. A common mistake is assuming data is ready to use. Phase II often reveals significant gaps that need to be addressed through additional collection, partnerships, or synthetic data strategies. Phase III is where raw data is transformed into something a model can actually learn from. Data in the real world is messy. It contains errors, inconsistencies, missing values, and biases that will degrade model performance if not addressed. Key talking points. Data preparation is consistently reported as the most time-consuming phase of any AI project, often accounting for 60 to 80% of project effort. Labeling is a particularly significant activity for supervised learning projects. Poor labeling directly degrades model accuracy. Augmentation techniques are used to expand training datasets, especially in domains where labeled data is scarce, such as medical imaging or rare event detection. Version-controlled pipelines are essential. The team must be able to reproduce any dataset snapshot used to train a model for debugging, auditing, and regulatory compliance. Compliance controls established in Phase II are implemented here: data anonymization, consent verification, and access logging. Phase IV is the creative and experimental heart of the CPMAI lifecycle. This is where the machine learning models are actually built, trained, and refined. Key talking points. Algorithm selection should always be driven by the business objective defined in Phase I, not by what is most technically interesting or currently fashionable. Iterative experimentation is expected. Teams typically run multiple training cycles, adjusting hyperparameters and testing different approaches. Validation on held-out datasets is non-negotiable. Without it, overfitting, where the model performs well on training data but poorly on new data, goes undetected. Model cards are introduced here as transparency artifacts. They document the model's intended use, training data, performance metrics, and known limitations. Ensemble approaches combining multiple models are explored when a single model does not achieve the required performance threshold. All experimentation should be tracked systematically. Undocumented experiments cannot be reproduced, audited, or handed over. Phase V is the quality gate before deployment. Its purpose is to verify that the model does what it is supposed to do, not just technically, but in terms of fairness, reliability, and explainability. Key talking points. Evaluation goes beyond accuracy metrics. A model can be highly accurate overall while performing poorly for specific demographic groups or edge cases. Bias and fairness testing is mandatory. Drift detection establishes a baseline for what normal model behavior looks like. This baseline is essential for catching degradation in production. Explainability is increasingly required by regulators and business stakeholders alike. If the model cannot explain why it made a decision, it may not be usable in high-stakes domains such as finance, healthcare, or HR. The go-far, no-go decision at the end of this phase is a formal milestone. It requires sign-off from technical, business, and governance stakeholders, not just the data science team. Teams may loop back to Phase 3 or IV if evaluation reveals fundamental data or model issues. That iteration is normal and expected in CPMAI. Phase VI is where the AI system moves from a controlled environment into the real world. Operationalization is about making AI reliable, governed, and continuously improving in production. Key talking points. Deployment is not the finish line, it is the starting line for ongoing management. Production models degrade over time as the world changes around them. MLOps practices, automated retraining pipelines, monitoring dashboards, and alerting systems are put in place to detect and respond to model drift. AI governance frameworks define accountability, who is responsible for model decisions, who can override them, and how errors are escalated and resolved. Change management is often underestimated. End users and business stakeholders need to trust the AI system, understand its outputs, and know its limitations. Adoption does not happen automatically. The continuous improvement roadmap ensures the AI system evolves as business needs, data distributions, and regulatory requirements change. Responsible scaling means expanding the system's scope or user base only when governance, monitoring, and support structures are ready. This slide brings together the two practical next steps for anyone in the room who wants to pursue the PMI-CPMAI certification. On the left, the certification itself. There are no prerequisites. You do not need a PMP, a technical background, or prior AI experience. You simply need to be 18 or over and complete the exam prep course. The exam is 120 scenario-based questions delivered in 160 minutes through Pearson VUE. It can be taken online with remote proctoring or at a physical testing center. You have up to 3 attempts within the 90-day eligibility window. Completing the prep course earns 21 PDUs, which is significant if you already hold a PMP. It covers more than a third of the 60 PDUs required for PMP renewal over 3 years. On the right, the Udemy practice exam course. This is an independently developed course with 5 full sets of practice questions, all aligned to the latest exam content outline. Each test is differentiated. Test 1 focuses on core AI concepts, Test 2 on scenario-based decision-making, Test 3 is updated monthly to reflect current exam trends, Test 4 targets advanced and challenging questions, and Test 5 maps to the VA ECO and the AI guide. Every question includes a detailed explanation, so you learn the reasoning behind the correct answer, not just whether you got it right. The direct link is shown at the bottom of the slide. Encourage participants to scan or note it down.